Let's look at how to handle missing values and outliers that may be present in your dataset. Typically, most datasets that you would encounter in real life will have missing values. But the dataset that we are dealing with, that is CA school, does not have missing values. So what we will do is I'm going to artificially introduce some missing values in the dataset and look at various methods of how to deal with those missing values. This is a bit advantageous because we know the actual values and we will be predicting the missing values also, so that we can compare how the different methods of missing value imputation are performing. For this exercise, I'm going to be using the mice DMWR and HMISE package. These are very common, very useful packages. Mice is used for missing value imputation. DMWR and HMISE we will see shortly. Apart from handling missing values, we will also see how to detect outliers in each of the columns in your dataset. If you have not installed all these, you need to run install.packages as usual. Let me load up HMISE. Options SkyPen equal to 999 will enable any decimal points being rounded off as scientific notations to be shown as decimal points itself. So it's a standard option that we will use. First step, I am importing the dataset. I am storing it in df orig. So df orig will contain the original version of the dataset. Here I'm grouping the different columns in the dataset as numeric variables, categorical variables. Test SCR, that is going to be the y variable that we are going to predict. There are certain variables that we don't care about because it's not useful information. So those are dropwares. Now, first step that we are going to do is to introduce some missing values. So here I'm setting the seed first so that whatever missing values I'm going to introduce is going to be reproducible. I'm introducing 15 different missing values in these columns: total enrollment, CalW percentage, and teachers. In these columns, I am introducing NA values. NA stands for missing values in R. Now, if you look at DF numeric VAS, there should be NAs here and there. There's an NA here, there is an NA here. These are all missing values that we just introduced. So this is how the data set now looks like. The columns that we are interested in right now is these three, the first three columns. Now, a very common, very naive approach of treating or replacing missing values. We call the act of replacing missing values as imputation generally. So when someone says imputing missing values, it means you are replacing the missing values with some meaningful value. A very common meaningful value is to replace the missings with the mean of the column. In HMISE, there is a nice function called impute that will allow you to replace the missing values based on various functions you can define. So impute, pass the name of the column, pass the column itself, then specify the function based on which the missing value should be computed. So if you run this, all the missing values that were present in this column will be replaced by the mean of all the remaining values in this column. Applying the same on the other two variables will give the respective new columns. Likewise, an alternate approach is to replace it with the median. This is also very common. In fact, median is more common than replacing with mean. You can do that using impute. Now, this does not replace this column, that is df dollar teachers. On running this, the column does not get replaced. It is just giving the output. If you want to actually replace it, you need to make the assignment like this. For now, I will not do this because in the next step, I am going to evaluate how the mean replacement is performing. DMWR, data mining with R, is a package that provides this nice, very nice, useful function called regar.eval. Basically, what this function does is you need to provide this function with the actual values of the continuous variable and the predicted values of the continuous variable. It will display various evaluation measures such as mean squared error, root mean squared error, mean absolute percentage error. We will see that shortly. But before going to that, I am going to capture in actuals variable all the actual values of the variables that are missing. So these are the values that are missing in total enrollment variable. These are the values that are actually missing in. So this I'm getting it from the original data set that contains the actual values. Whichever position that is missing, I am passing it as the index. So these are the actual values that went missing. All right. Now I'm replacing all of these with the mean of that column. Now all the predictions is the mean of DF dollar total enrollment. All right. So instead of this value, we are going to be replacing it with a mean will result in these values. As you can see, the predicted values is very bad. It's very far from the what the actual scenario is. So naturally, I would expect the root mean squared error, mean squared error, and mean absolute error. All these are very high values, but I normally refer to MAPE. MAPE is a value that is comparable. That is, even if the scale of the variable, be it the variable is in tens, be it in hundreds, be it in thousands, 10,000s, or whatever be the scale of the variable, the absolute percentage error is a percentage value. So if you have one variable that is having a MAPE of say 0.3, that is 30%, another variable that is in lakhs or hundred thousands, it is having a MAPE of tens, you can compare how well your predictions have performed. In that sense, MAPE is useful. Likewise, let me compute the MAPE for the other variable 45%. 4500, this is 44,500% is the MAPE here. Likewise, let's do it for the other variable as well. Here 200% is the MAPE. To be more precise, it is 225.51%. Now that's very bad. That's a very bad prediction. Let's confirm it by looking at the actual values itself. All right, now let's look at the second approach, which is prediction modeling based approach. This is based on, or this is present in the mice package. You need to install mice if you haven't done so already. Here, there are two steps that you need to perform to do missing value imputation. The good thing about the mice package is you can impute all the columns in your data set using one single function, or rather two functions to be precise. First step is to call the mice function, pass in all the columns in your dataset except the Y column. Here I have excluded test SCR column from the dataset that I am passing to mice. Specify the name of the algorithm that mice should use to predict the missing values. So it is predicting the missing values based on the other columns and values present in the other columns in the dataset. What this means is it is using random forest to predict a missing value that may be present in say total enrollment variable, right? So first it builds the model, then use the complete function, pass in the model to get the resulting completed dataset. That's all there is to it. This takes a bit of time. I'm going to fast forward until it completes the code. The code has run. Now let's check the MAPE. 76%, 79%, 37%. It is still not perfect, but it is way better than what we achieved when we used the mean imputation. Well, this is not the only option with mice. If you check out the help page for mice, there are a bunch of options. You could try out using different ways of imputing the mean that is present within the mice package itself. So instead of using RF here, you can substitute RF with any of these methods that are present. Just pay attention to what type of variable that you are going to impute it. For example, if your dataset contains numeric categorical variables combinedly, then you might want to use any of these variables. Whereas certain other imputation methods will work only on numeric variables, whereas certain others like logistic regression and such will not work on numeric. So that's about handling missing values. Now let's look at outlier analysis.